back to proving triangles congruent. And so we have side, side, side. And that's theorem 5.8. May be able to imagine what it's going to say, but if three sides of a triangle, I think it's going to say it slightly different. Let's go back. If three sides of one triangle are congruent to three sides in another triangle, then the triangles are congruent. So basically, in order to use this theorem, at some point you would need to say in a proof that all three sides are congruent. So to just review really quickly kind of our steps to writing a proof, and it doesn't mean that there'll be this many steps in the problem, but we're going to write down the given. We're going to make conclusions. From the given. We're going to use the picture. Writing too fast. And what I mean by use the picture, this is where we're going to typically say use the reflexive property or vertical angles, depending on the problem. And then that should be good enough. We're at the prove part. Okay, so side, side, side theorem, like for doing a proof, is usually really straightforward. Let's see if I can. This picture you'll see kind of a lot. So if I said given B is midpoint of AC and AD is congruent to CD, prove triangle ABD is congruent to CBD. So step one, V is a midpoint and AD is congruent to CD. So right here you have, let me write it differently. You have a side that is congruent, and all this reason would be given. Okay, B is a midpoint. What's conclusion? Well, that means it's in the middle. That means that both sides are congruent, and so that's definition of a midpoint. So here's another side congruent. So I've written the given, I've made conclusions. If something's congruent, that's all the conclusions that you need. Then I'm going to use the picture, and remember that that's a lot of the time going to be reflexive property. BD is congruent to itself. Reflexive, and there's three sides. So it was given to me that those were congruent. I concluded that those were congruent, and then I did reflexive for that middle one. So then triangle ABD is congruent to triangle CBD. Side, side, side. Okay. All right. And just remember that if you notice in this statement that the letters go follow the same kind of pattern, I guess, if you will, but from A to B is that short side, so then on the other triangle it has to go C to B, and then B goes up to D. Like, it has to follow that same order. So if I said ABD is congruent to triangle CDB, that's not right, because it doesn't follow the same, like C to D isn't the same as A to B. It has to follow that same order. So in the proofs, that will not be an issue, but in some of the other problems, it will. So you need to make sure that it's following the corresponding order when you do the problem. So there's a direct set of directions that say decide whether the congruence statement is true. The triangles very well may be congruent, but this statement right here is not true, even though the triangles are congruent. So just make sure that you're following the right order when you look at some of those. Okay, so there's another triangle theorem, Theorem 5.9. It's called Hypotenuse Leg, or HL. Excuse me. So the theorem's kind of long, but if the hypotenuse and a leg in a triangle, or of a right triangle, forgot the word of a right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. So to use hypotenuse leg in a proof, you need to say three things. You need to say that you have right triangles, and then you have to have the hypotenuse congruent, which is the side across from the right angle, and you must say that a leg is congruent. And this one can be kind of tricky at times. And I'll show you what I mean by that. So to use HL, I have to have right triangles, I have to have the hypotenuse congruent, and I have to have a leg congruent. It's kind of a different picture. Okay, so given WY is congruent to xz, and wz is perpendicular to zy, and xy is perpendicular to zy. Prove triangle WYZ is congruent to XZY. Okay, so part of the challenge to this problem is that we have overlapping triangles. So WYZ, I'm going to draw it a little bit smaller just to save some room. But WYZ looks like that. And then XZY is that one. So I think on a problem like this, it's helpful to separate them. Okay, so on step number 1, I'm not going to rewrite it just to save some room, but all that stuff up there is the given. And in the given, it gives us that WY and XZ are congruent. Alright, so perpendicular. WZ is perpendicular, XY is perpendicular. Okay, so when things are perpendicular, they form right angles. That's the conclusion that you have to make. There's no other conclusion that you can say. So WZ, this one on the left, is perpendicular to ZY, so I can say that angle WZY is a right angle, not triangle, an angle. And I can say that angle XYZ is a right angle. And that's just the definition of perpendicular. So, here's the challenge. In some proofs, I can say that right angles are congruent. Okay, like I can say that, that's true. Right angles are congruent. And so we talked about like side angle side the other day, and I need an angle to be congruent, so maybe a right angle being congruent like works. So I'm just going to make the right angle symbol. But hopefully you can see that if you said that the angle is congruent, well, then WZ and XY would have to be congruent in the left triangle, and XY and ZY would have to be congruent to make it side angle side to go in order. But what I have is the side across from it. So it's not going to be like, that's not going to help me to say that those angles are congruent. But maybe you've noticed that, maybe you haven't, but ZY and ZY. So I'm going to be able to say that those two are congruent. They're the same line, they're the same segment in both triangles. That's going to be a reflexive. Okay, so if I'm going to say that this side and this side are congruent, then I do have the hypotenuse, because that's a right angle, and a leg. Okay, but I need to, remember if you go back, right now I have the hypotenuse is congruent because they gave that to me in the given. I don't have right triangles yet, and I don't have a leg yet. So perpendicular, they're right angles, and then I can say triangle WYZ and triangle XZY are right triangles, and that's just definition of right triangles. The definition of a right triangle is it has a right angle. Well, it has a right angle. Okay. Now I can do zy is congruent to zy reflexive. And then I can say that triangle WYZ is congruent to triangle XZY hypotenuse leg. So the one thing that you'll want to keep in mind when you see perpendicular, the first thing you're going to write is that they are right angles, no matter what. Then you have to try to determine, am I going to use hypotenuse leg with the right angle, or am I going to use a side angle side, or something with the angle? Little hint, today's section has hypotenuse leg in it, so that's probably what you're going to do. But just moving forward, you'll need to try to determine that. So the other thing to remember with perpendicular is that you're going to write two steps after that you have been told perpendicular, like in a given. You're going to write right angles and then right angles are congruent, or you're going to write right angles and then you have right triangles. So it's two steps no matter what. Okay? So the problems today will be, decide whether there's enough information to prove the triangles are congruent using side, side, side. Is there enough information to do hypotenuse leg? Is the congruent statement true? So remember, the order has to be right. So like on this one, the order on a proof, it's always right. But like I could not say WZY is congruent to ZYX, because it doesn't follow the same order. Okay, like the X goes with the W, so it would have to start with X. It went W and then down to the right angle, which is Z, so it would have to be X to the Y. Okay, so you'll have, is the congruent statement correct? And then you'll have a couple proofs to do. Maybe more than just a couple. It looks like there's maybe 4. Now there's 3. Okay, so, but follow the pattern. These proofs should hopefully be easier than the other ones for you. So keep working at them. You'll get better at them, I promise. All right, have a good rest of your day. We'll see you tomorrow, guys.